Welcome back to our module number 14. This module we look into network address translation. So we have 5 chapters here. So let's look into the basic what is NAT overview. So why do we need NAT? So first we look into motivation behind NAT. As the number of internet users increases, public IPv4 addresses become scarce. What's worse, even allocation of these addresses has resulted in severe shortage of available public IPv4 address in some area. Remember that in our IP, we only have 2 to the power of 32. So that equivalent about 4.2 billion IP address that we have. So the world population is already close to 7 billion. So if every one of us use the IPv4 at the same time, we will run our IP. So the motivation here is to overcome the public IP shortage, okay, which is the IPv4 address shortage. It's necessary to use transition technology. But again, this is one of the technology we use. Right now, we all know that we also have the IPv6. But we are not going to look into IPv6 at this moment because majority of us are still in IPv4. So here we have the internet user who want to go into the internet. When you go to internet, you do need to use IPv4, and we are running out of IPv4 now. So that is the motivation behind why we need network address translation. Now let's look into what we call the private IP addresses. Before we look into the private IP, first we already mentioned we need to have IP address. So we do have public and private. So public IP address are managed and allocated by dedicated organization and can be used for direct communication over the internet. So the organization who manage is called IANA, or Internet Assigned Number Authority. Okay, so that is the organization who manage public IP addresses. Whereas the private IP addresses can be used by organization or individual randomly on internal network. So the keyword here is internal network, but cannot be used for direct communication on the internet. So remember here, the keyword here is for you to go to internet, you need to use public IP. If you want to use for internal network, then you can use private IP address. You can use it as a company, organization, or individual. So here we have different type of a class A, Class B, and Class C of a private IP address. So the private IP address here, we have a Class A, which is from 10.0.0.0 to 10.255.255.255. That's for Class A. Then we have Class B of 172.16.0.0 to 172.31.255.255. And lastly, we have 192.168.0.0 to 192.168.255.255. So remember, for the internet, we need to use the public IP. For small organization or even big enterprise, you also can actually use private IP. Okay, so how we can use private IP yet we can connect to the internet? This is where the technology called NAT will help. So here we look into NAT implementation. So NAT, or network address translation, translates IP addresses in an IP packet. Is widely used on live network and is usually deployed on network egress devices such as router or firewall. Typical NAT application scenario would like this. Private addresses are used on private network. It can be enterprise or home. So in this diagram, you can see that here we have the private network. And you can see also that the source is 192.168.1.10. And this network is basically our private IP address. And NAT is deployed on egress device For traffic from internal network to external network, NAT translates the source address of the data packet into a specific public addresses. Now, if you go back into this diagram, you can see that here I have a source IP address of 192.168.1.10, and this user would like to go into this network, which is 200.1.2.3. Here we have the public IP. This is a public IP. So the question here is, a private IP will not able to connect to the internet directly. We learned that on the previous slide. So for us to overcome this, we need to use network address translation. So the router will perform the network address translation, who translate. You notice that the router have two interfaces. One which is the internal, another one which is the external. If you look carefully here, the source IP, which is from 192.168.1.10, it being translated to 122.1.2.1. Here we are translating from a private IP address into a public IP address on the router. You get it? So in essence, this is how NAT works. So it translates from the private IP into a public IP. For traffic from external network to an internal network, NAT translates the destination address of the data packet. Now this is important, as you can see that just now we are translating the source, okay, from a private to public. Now you look here, is that the destination is 122.2.1. It go to NAT, and you notice over here the destination has been translated back into the private IP address. So NAT allow you to translate a source from private to the public for the egress. That means you are accessing outside, and for the ingress from the destination, which is the reply packet to the destination, it is translate the destination from a public IP into the private IP. So by doing this, you are conserve the public IP v4 address. So in essence, using the private network, you can use a private IP and share a single public IP address. Hence, you are saving public IPv4. So let's look into chapter number 2, static NAT. So let's look into the static NAT implementation. The definition of static NAT. A static NAT is a private IP address is mapped to a fixed public IP address. Okay, so remember, internal, there's one private IP mapped into external, one public IP. Then we also have a definition of bidirectional access. When an internal host with a private IP address access the internet, the egress NAT device, which is the egress, which is this part here, is translate the private IP address into public IP address. So when you do the NAT on this router, this part here, the interface on the egress will actually do the translation. Similarly, when an external network device send packet to an internal network, the NAT translate the public address, carry in the packet into the private address. So there are two directions here. One is from your private going outside. So this is one way. So you are doing a translation from private into public. Another side here is that from outside going into inside. So again, you are going to translate from a public into a private. In this example, you can see I have a translation. 192.168.1.1 is being mapped into 122.1.2.1. So this is a public IP I have. Then I have another IP, which is 192.168.1.2 being mapped to 122.122. And number 3 here, mapped to number 3. Again, this is very important that you have the public IP address pool. Remember a few slides earlier on, I mentioned that you need to have own the public IP address, and you need to get it from IANA. All right, so assuming that these are the public IP address that is being assigned to you so that you can use this range of IP address. So here we look into the mechanism on how NAT work. So we have two examples. Let's have a look in more detail. So on the first step, we have the source of 192.168.1.1, and this IP want to access to 200.1.2.3, which is this web server. Now I want you to take a very close look into the source IP. 192.168.1.1 is being translated to 122.2.1. What you can see from here, this is a public IP. Of course that the 200 is also a public. So what is being translated is this part here. So as you can see here, the source from private is being translated into the public. And let's look into step number 3. As you can see that step number 3, the source now is 200.123 because now you are actually replying to the NAT router, and you can see that the destination is 122.121. So when step number 3 here happened, the packet reached to NAT, what the NAT does is that it's actually translate back into 192.168.1.1. So this is where you are doing an egress traffic. What if I have the internal, which is I have a resource here, which is 192.168.1.3 is my internal resource, that I have an external host here who want to go into your internal resource here. So for the second example here, you can see that step number 1, the source IP is a public IP 202.123, and I'm going to 122.1.2.3. Both of these also a public IP. When it reach into the NAT server, which is here, this is my NAT server, it will actually do a translation. Look into this translation. The destination of 122.123 is being translated into 192.168.1.3. Similarly, when this host reply, as you can see that original host is a private, and when it pass through the NAT, this private IP address is being translated into a public IP address 122.123. So we call this as a static NAT. Now the advantages of static NAT is for every single IP address internally, you will map into external IP address. So you are not saving IP address, but you are actually mapping and translating one to one. It is good if, let's say, in the network you have some resources that you want to allow external to come to you. For example, here we have 192.168.1.3 is a resources that's internal, but you do allow external hosts to access to your internal. So typically in this case, we will use static NAT. Right, so let's look into the configuration of static NAT. So for you to configure static NAT, we are going to do two methods for us to do it. So method number 1 is that we configure from the interface view. So whichever external interface that you want to do the NAT, you are going to go into that particular interface. So assuming that this is gate 000, which is our external interface, which is facing the internet, the first command we are going to use will be NAT static global. Okay, then you are going to specify what is your external IP. Then you use a keyword which is inside, and then followed by your internal IP address, which is just now the example is 192.168.1.x. So here we have an explanation. Global, which is a global address, is used to configure an external IP, and inside is used to configure the internal private IP address. Now there are two methods as I mentioned. The method number 2 is you are going to configure on a system view. On system view, you still do the same thing using NAT static global. Then you are going to specify the global address inside and the host address. It's similar just like on the interface, except that after the command is configured, you need to specify on the interface. In this case, you are going to specify that this is my external interface. Then you are going to specify NAT static enable. Okay, so this is a command that you need to enable, telling the router which interface is the NAT interface. All right, so we have two flavor that you can use. Either one of them will work. So here we are looking into the example of configuring static NAT. Here in this example, we have a topology. We have 3 hosts here, 1.1, 1.2, and 1.3, which is using private network connecting to a switch, and then the switch connect to a router. The router have a gateway of 192.168.1.254, and the router also have a interface which have a IP address of 122.1.2.1, which is connecting to the internet, and we have an external web server which is 200.1.2.3. So let's look into the configuration specifically on NAT. So on the internal, we do not need to do anything. It's only on the external interface gig 001, which is IP address of 122.121. We just need to do these 3 configuration. So the first one is NAT static global. 122.121 is the external or public IP. Then we specify internal or inside is 192.168.1.2, and you repeat it on the external IP address. Now again, this IP address is being assigned to you, and this is your internal IP. Okay, all these are internal IP address. So that's all. So just using these 3 commands, you're able to allow the internal to the external using the public IP address. As I mentioned again, these are the public address that is owned by the company, and this is one-to-one mapping. You are not saving any IP address here. So to give you an idea on how this is being configured, so let me show you the lab. So this is a demo that I pre-configured. So again, this is very similar to what we have on the diagram just now. We have PC 1, 2, and 3, which is 192.168.1.x. Then we have our switch here, which is layer 2. Then we have gig 00, which IP address is 192.168.1.254. External, we have 122.2.1 connecting to the cloud. In this case, this is the internet. And finally, we have a server here. Okay, so let's us look into the nets here. All right, so this is a newly start router. Currently, there is no configuration. Okay, so I'm going to show you how this is being configured. On the internal, we have the IP address of 192.168.1.254, and in the external, which is gig 001, we have the IP address of 122.1.2.1. So that's it. And let's see if we can ping to the internal. This is a PC number 1, and in PC number 1, you notice that we have 1.1. So I go back to the NAT here. I do a ping to 192.168.1.1. Okay, so let me change this 168. Right, so as you can see that I can able to ping. I can ping to number 2, which is PC 2, and I also can ping to PC number 3. As I mentioned here is that the gateway, we are pointing to 254. Okay, so 254 is our NAT routers here. So it's a basic layer 2 configuration. Then on the NAT server, we are going to point to our cloud, in this case our service provider. So since this is a service provider, I'm going to configure our static route. So let me change my router to call as a NAT. I can ping to my service provider 122.1.2.2. So this is .2 interface, which is I'm simulating this as my service provider. You can see that 122.1.2.2 is my provider, and I'm going to use a IP static route, IP route static. So I use a default route, and I'm pointing to 122.1.2.2. That's it. So now I already point to my service provider, and in return I should able to ping to the internet. So I'm assuming that the server 1, which having an IP address of 200.123, is the internet IP address 200.1.2.3. So as you can see that I'm able to ping here, and when I do a trace, of 200.1.2.3 are passing through the service provider before it landed into the server. So basically the cloud behind here is just a router. Now how we can configure static NAT here? So let me go back to PC number 1 here. So in PC number 1, I'm going to do a ping to 200.1.2.3. Remember, NAT have not configured yet. So we are going to configure the NAT now. You can see that it's request timeout, right? So we are going to do a configuration. Okay, so I'm going to put in the configuration here. So this is a configuration for the NAT. All right, so let's just configure that. Okay, let me move this. On the NAT server, I'm going to specify the interface of gig 001. So I'm going to go into the interface gig 0/0/1. Remember, I have already have IP here. Then I'm going to use a keyword called NAT static global. Okay, 122.1.2. Now I'm using 1 already, so I'm going to use 11. So I'm going to do an inside 192.168.1.1. Okay, you see this, huh? So the command is called NAT static global 122.1.2.11. So I'm assuming that my outside IP address is 122.1.2.11 and my inside IP is 192.168.1.1. All right, enter and see what happened. Just now I have a timeout. Now I can able to ping. And when I try to do a ping, what it does over here is that it will go into my router. Then my router will translate it into 122.121 and it will send to the COM server. Now if you want to verify this, what I'm going to do here is I'm going to run a Wireshark and I'm going to show you how this is working. Okay, so I'm running my Wireshark over here. I'll show how the NAT here is working. So I do a ping one more time. Okay, and I shift back to Wireshark. Alright, so as you can see here, I have 122.1.2.11. Remember that my external IP is 122.1.2.1 and this is my destination. You notice that then it will actually get a reply back from the server 200.1.2.3 reply to 122.1.2.11. So this is the NAT in action. So as what I mentioned earlier on the concept, the source IP address from 192.168.1.1 has been translated to 122.1.2.11. So this is where I can able to ping. Now assuming that I go to PC2, do you think that now I can ping to 200.1.2.3? It will not, right? Because I still do not have a translation here. So let's do the translation and see the ping will take place. So I just do an up arrow. So what I'm going to do is, so instead of 122.1.2.11, let's say I'm going to do 122.1.2.2. Okay, and then I'm going to do an inside of 192.168.1.2. Enter. So this time I'm using 122.1.2.2 and I'm going to do a ping now, and you can see you can ping already. Okay, so we can able to ping. So let's continue to do the next NAT static global 122.1.2.3. inside is 192.168.1.3. Okay, so display this. So now we have all the setting here. So this is how NAT, static NAT is being configured. Alright, so chapter number 3, we look into dynamic NAT. So let's look into definition of dynamic NAT. Dynamic NAT is a private IP address is mapped to a public IP address from NAT address pool. Alright, so the keyword here is an address pool containing a group of public IP addresses. Static NAT strictly map addresses in one-to-one mode. So that is the main difference. Static is one-to-one, whereas dynamic is many-to-many. As a result, even if an internal host is offline for a long time, or does not send data, the public address is still occupied by the host. This is the disadvantage of using a static. So dynamic NAT prevents such address waste. When an internal host accesses an external network, and available IP addresses in a NAT address pool is temporarily assigned to the host and make it as in use. So again, you can see here we have a temporarily assigned. So once the user don't use it, it will be released. So when the host no longer access the external network, the assigned IP is reclaimed and marked as not used. This is the example here. In the pool, we have 122.1.2.1.2.2 and .2.3. So currently, none of it is being used. So assuming if the 192.168.1.1 accessing the internet, so what will happen here is it will use, and this will mark as in use, and we have two more IP address is not being used. And once this 192.168.1.1 shut down, what will happen here is this one will release again. So that is the theory on dynamic NAT. So let's look into the example here. So we have two parts in this example. So on the first step, you can see here, step number 1, IP source of 192.168.1.1 initiate a connection to 200.123, which in this case, this is the server. It will go into the NAT, and the NAT randomly select an IP address in the pool. So in here, we have 122.1.2.2 is being selected. So that is step number 2. And since you select 122.1.2.2, the source is being translated. Okay, the destination will remain the same, and it will reach to the destination. When the destination reply, it will use the 122.1.2.2 as a destination. So in our NAT mapping table, you can see that 192.168.1.1 are being mapped to 122.1.2.2. Whereas if let's say there is 192.168.1.2, so for example, if this guy go out and 122.1.2.1 is being selected. So this is the example, part number 1. So when the web server reply, as you can see here, step number 3, we have the source of 200.123, in this case, the web server IP address. The destination is 122.1.2.2, which basically match to 192.168.1.1, which is mapped into the PC number 1. Okay, so I think that this is easy to understand. The difference over here is they are using a pool instead of a static mapping. So let's look into configuring dynamic NAT. So we have a few steps here. So step number 1 is to create an address pool, and the command for you to do that is called NAT address group, and you are going to specify what is the start IP and what is the end IP. Of course that this start IP and end IP is the IP address of your public address range. Okay, so once you specify that, step number 2 is to configure ACL. Now, why we need to configure ACL? Configuring ACL allows you to match what are the internal IP that is allowed to do NAT. Okay, so we learned about NAT earlier on topic. We look into the source IP and using the ACL wildcard. So you need to configure the ACL. It can be a basic ACL or it can be advanced ACL. So for our NAT, we will use basic ACL. So that's step number 2. Step number 3, we are going to configure an outbound NAT interface with the address pool in the interface view. So remember, it is in interface view. We are going to use a command called NAT outbound using the ACL. So the ACL number here is referring to the ACL number here, this tied together, and the address group here referring to the address group over here. Then we have the group index. This is the group index, that is our name. Then we also have a start and end address. And there's a keyword here. You notice that that is called NOPAT. So associate the ACL rules with the address pool for dynamic NAT on the interface. The NOPAT parameters specify that port address translation is not performed. No worry about no PAT here, because the next slide after this we are going to explain what it means by PAT. So here we have the similar topology, but this time instead of using static NAT, we are using dynamic NAT. The topology is the same. We have 3 PC, we have the NAT router, we also have the same external server, which is 200.1.2.3, and you can see here our configuration. Remember earlier on I told you step number 1, we have to define our address pool, and the address pool index name is called 1. Okay, in this example it choose 1 as the address pool index. Then we have ACL 2000. ACL 2000 is a basic ACL. Then we have the rules number 5, permit source 192.168.1.0. In this case means that anything with 192.168.1.0 with a wildcard of 0.0.0.255, which means the entire subnet of 192.168.1.0. And we are going to do step number 4 here, NAT outbound 2000, address group 1, no PAT. Next we look into chapter number 4, NAPT and Easy IP. So let's look into NAPT implementation. Dynamic NAT does not translate port number. It belongs to no port address translation. Remember earlier on I mentioned we have a keyword called no PAT. In this mode, the mapping between public and the private address is still 1-to-1, alright, which cannot improve public address utilization. So just to recap, static means that we have 1-to-1, even though the computer shut down, it will still be reserved. Dynamic NAT means that we still have 1-to-1. Improvement here is when the computer shut down, then we can reuse the public IP. Whereas if we are using NAPT, we can use port address translation. So the improvement over here is NA stands for network address and PT stands for port translation. So this is where we have NAPT. It translates both IP address and port number from multiple internal hosts to one public address in the address pool. In this way, 1-to-N mapping between public and private address is implemented, which effectively improves public address utilization. This is what we want to achieve, which means that we can do many-to-one mapping. And for them to do that, instead of just using IP to IP mapping, they also do IP to port mapping. So let's look into how this is being achieved. As you can see, we still have the 3 machine in the previous topology, and our IP address on internal is still 192.168.1.254, and the public IP is still 122.1.2.1. We have an address pool here, which is in this case we have 2.1, 2.2 and 2.3. But instead of just using the IP, you notice that we're also using what we call the port number. For example, if you can see here, we have 192.168.1.1/10321, which is our private IP, is being mapped into 122.1.2.2.1025. Now, if I have a second internal IP that is using the NAPT, you notice that this time they are using a different internal IP and the port address. But this is where it's become interesting. You notice over here, the public IP is still 122.1.2.2, and here you notice that the port number is 1026. As its name suggests, NAPTs, they are using network address translation with a port translation as well. So they're combining both techniques together. With this, the advantage is I'm just using a single public IP, yet I can use multiple internal IP to do the translation. So this is the NAPT concept. So let's look into the mechanism on how we can achieve this. So on the first step, right, so we have our source IP with the port number is being sent to the NAT server. Okay, so the NAT select one of the public IP. In this case, it's selected 122.1.2.2. So this is step number 1. So this IP address is being sent together with the port number of source 1025 port number with the IP address of 122.1.2.2 sent to the destination. When destination reply, you notice that in step number 2, it generates a NAT mapping address which record the address and the number. See what will happen here is the server is reply back to 1025 and is being mapped into the NAT, and once it's replied back into 1025, it know that I will map back into 192.168.1.1, and this is the port number that's originally I sourced from 10321. All this information is in our NAT server, and you also can see from here if I actually using 122.1.2.2, but when I reply to 1026 here, you notice my IP address is not 1.1 but is 1.2. So this is how NAPT work. And we also have step number 3 and number 4. Basically it's the same. So when we are replying or when we connecting from the server back into the NAT, so you can see that here we have a reply which is mapped back into our internal host. So the keyword here is our NAT mapping table in our router. So for us to configure NAPT is also pretty easy as compared to the static and dynamic. This time we still have our NAT pool. So we are going to create NAT address pool. You notice that they are creating only one pool. So we have our ACL, okay, just like the dynamic. Then here you notice that we are using NAT outbound 2000 address group 1. So this is the NAPT configuration. Let's look into another way for us to configure this. We call easy IP. Alright, so easy IP and NAPT is about the same, but there is one slight difference. Okay, so let's look into easy IP. Easy IP translate both IP address and transport layer port number. The implementation of easy IP is the same as the NAPT. The difference is easy IP does not involve address pool. It uses an interface address as a public address for NAT, which means that in the NAPT, I can assign another public IP. Whereas for easy IP, whatever IP address that is on the interface, in this case, I have the external interface. This is my internal interface. Internal interface is always the same. The external interface will be used as the address to go out. Easy IP apply to this scenario where public IP are not fixed. Example here will be the IP address that is given to you dynamically. If you are using ADSL or using a service provider where you subscribe a dynamic IP, so you cannot create a pool. So since you cannot create a pool, then you have to use the PAT or easy IP. So this is where I mentioned here, if you are using dynamic IP or PPPoE dial-up. Okay, so let's look into the configuration because the theory on the NAPT and easy IP is identical. So let's look into the easy IP configuration. So based on this topology, it's the same topology. I want you to take note on the configuration. There is no address group. Okay, you do not need to create the pool. Now you just have to say that what is the ACL, in this ACL, which IP address is allowed to translate. And then I just go to the interface and I just have to specify NAT outbound 2000. That's it. This is so simple. This is how you can configure easy IP. Okay. Right, and we look into the final topic here, chapter number 5, NAT server. So NAT server map an internal server to a public network through a one-to-one mapping between a public address port number and a private IP port number. This function is used when the internal server need to provide service to the public network. So an external host proactively access the public IP with the port number to communicate with the internal server. So we call that as a NAT server. Some of the vendor, they also call port forwarding. Okay, so the concept is very similar to our static, except that static is only purely based on IP, but NAT server based on both IP address and the port number. So here I have a port number of 122.121:80. So this is where I have my public IP and port number 80, but I'm not interested to go to the router web server. I will map it back into my internal 192.168.1.10 port 80. My web server is here. Okay, so this is called NAT server. So let's look into the mechanism on how this one works. If you already understand the static NAT, dynamic NAT, NAPT, and easy IP, then this one is basically the same. So let's look into the mechanism. On the first step, the source 200.123, this part here, with the port number of 47819, which is a random port number, accessing to the destination of 122.1.2.1, which is the NAT public IP. Now, because you are using port number 80, and based on my table over here, if you are looking for my public IP port 80, I'm going to map into 192.168.1.10:80, which is also port number 80 in my internal. So here I have 192.168.1.10 is also port number 80. So it actually reached to the web server. Now the web server is going to return and reply the packet. When it replies the packet, it's still using its own internal source IP, port number 80, but the destination right now, as you can see, is 200.1.2.3, which is belong to here. Okay, the port number, as you mentioned, as you can see from here, 47819, which is corresponding to the port number, is request from the source. And when you go through the NAT, you see what happened to the source here, 192.168.1.10 are being translated to 122.1.2.1:80, and the data will received by the requester. Okay, so this is a NAT server example. And for you to configure this is also very easy. On the NAT, the configuration will be something like this. Configure NAT server on R1 to map the internal server 192.168.1.10 with the port number 80 to the public IP address of 122.121 with the port 8080. Now, why do you want to change this number? Which means that if I have 200.123, this guy, looking for IP address of 122.121 with a port number 8080, I'm going to map into the web server. Now this is quite common because sometimes some of our router also have a web server, all right, which is port 80. So when you connect into your web server, port number 80, it will confuse the router thinking that they are really looking into the router web service instead of your internal web server. So for us to prevent this conflict, we are using another port number. So as you can see from this configuration, what you really need to do is on the external interface, you just have to specify this command, NAT server protocol TCP global 122.121 www, which is port number 80, inside which is 192.168.1.10, external is 8080. Okay, try this out. So some of the other vendors, they call it as a port forwarding, but on Huawei we just call it as a NAT server, so the concept is the same. So as a summary, in this topic we look into NAT, using private addresses on private network and using NAT at the egress effectively reduce the number of required public IPv4 addresses. NAT effectively elevated the shortage of public IPv4 address. Remember the PAT that we mentioned early on with the easy IP. Dynamic NAT, NAPT, and easy IP provide source address translation for private network to access to public network. NAT server enable internal server to provide services to public network. This is how we advertise our web server to external. Am I right? So for those of you who have your CCTV at home, most likely you are going to use a NAT server because your CCTV is using internal IP. If you have your application who want to access to your internal CCTV, you use NAT server. Static NAT provide one-to-one mapping and support bidirectional communication. Static mapping is just one-to-one. You just want to hide the IP address with the public IP to the private IP. Okay, so that's the end for this session. I will see you on the next module. Thank you. Bye-bye.